So on a lot of vehicles, especially diesel trucks, when you replace a fuel injector, you often have to code that injector into the vehicle's computer. And what it does, that coding, is it tells that computer how much fuel that injector is going to flow, because every fuel injector is going to flow a different amount of fuel. So on this Ford truck, it's a pretty easy procedure, so let's walk through it. This functional test is inside the engine, so we'll go in there, and then it's under functional tests. And then you see it right there, fuel injector quantity adjustment. So we'll click on that. The ignition's already on, so we'll just hit continue. And it says use the 10-digit code on top of the injector to program the injector. Do not confuse characters, for example, 8 and B, D and 0, when reading off the injectors. So I already wrote down the code on the one that's in there, so we'll hit continue. And it says on the next screen, record the current IQA codes for your record and select the injectors to be programmed. So we'll hit continue. It's going to display, and what displays is going to be all of the codes that are coded to the computer already. And we see there, injector 1, it's all 0, so we need to program that one in. So we'll just hit edit, and we'll program it in. Okay, hit OK when you're done. Do you want to program the new ID? There's the old one, there's the new one. You'll hit yes, program. And once we hit program, and now it says program new ID is successful, we'll hit continue. And there's that new code there. It's all set, all programmed, ready to go. There we go. There I am. Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, should see a little button that says Q&A. Click on that, type in your question. I'll get to those at the end of the session. If you're watching along on YouTube, feel free to use the live chat function. And as well, if you're on Zoom, and I put up a little poll here, we're just trying to get a little bit more of an idea of, whether or not we're going to continue to use Zoom or we just might do something else. But it seems like a lot of you use the Zoom for the certificate. So if you could just answer that poll, that'd be wonderful. We're just trying to collect a little bit more information on that. So thank you for that. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 12 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. And before I did that, it was 8 years at Subaru, so just worked in a dealership, and over time just became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Have been about 30 years under hood experience for me. So our topic here today is diesel emission systems operation and testing. And we're going to focus on light and medium duty, I guess, in the way. I suppose heavy duty emissions are also going to work in a very similar way. It's just going to be, at a bit larger of a scale, I guess. But we're going to focus mainly on the light duty up to 1 ton, so cars up to medium light trucks. So how do we control diesel emissions? There's a couple ways we can do it. We can do it within the combustion chamber by using different chamber designs, different ways of atomizing the fuel, different injection timing, EGR valves, for example, we're going to talk about. Different boost levels using variable geometry turbos, engine temperature controls and compression ratios, and more. It's really a lot up to the design and the accessories, I guess you could say, around the outside, right? So even with those controls and the engine changes, they have to do more after the fact, after diesel fuel is burned in the combustion chamber. So after the combustion, we're going to talk about the oxidation catalyst, the DPF or diesel particulate filter, and selective catalyst reduction or SCR system, which includes using the urea system or the AdBlue. You might have heard that called before as well. So we're going to get through a lot of these different systems. So we see if we go from the beginning, we start off We get fresh air coming through the turbo, and of course that gets run by the exhaust. We also have the variable geometry turbo, which can bring air back in through the cooler. We have EGR valve, intake throttle valve. If it has an EGR valve, it does have a throttle valve on it. Then we have the oxidation catalyst, the DPF, which we're going to have a pressure sensor on either side, a differential pressure sensor. So that's going to compare the inlet pressure to the outlet pressure to tell whether or not it's clogged. We also have the SCR down here, the selective catalyst reduction. Any of the DPF or the DEF injector is going to be the diesel exhaust fluid, is going to be ahead of that SCR. And some vehicles have the SCR first, some vehicles have the DPF first. It just depends on how the manufacturer decides to do it. But with the DEF system, you're going to have engine coolant lines to cool it up, warm it up, depending on the temperature outside. Supply module, filters, it could be an electric heater in there as well. Pressure lines, and then the actual injector itself. Then we have the SCR here, and then we might have a slip catalyst at the end. We need multiple NOx sensors. We're going to talk about those as well. So then it's going to measure the NOx going into the SCR, and it's the SCR's job to reduce the amount of NOx or oxides of nitrogen coming out the back. So the vehicle uses that to compare the inlet and the outlet there, plus multiple temperature sensors along the way as well. So diesel EGR is going to slow combustion to keep NOx or oxides of nitrogen from being generated. Allows for more advanced injection timing. Requires the use of EGR coolers as well because it's going to get pretty warm in there. Uses variable geometry turbos to raise exhaust back pressure and makes exhaust flow into the intake under low boost. So that's what part of the variable exhaust or variable geometry turbo is going to do for you. And they can get prone to clogging. Right, so introducing CO2 dilutes the air charge and slows down the flame front, dropping peak temps below 2,500 degrees. Also reduces fuel mileage and introduces soot back into the engine. So now since we've changed the combustion temperature, now we have more soot and we can clog it up with inside that EGR valve right there. You can see all that soot in there. So those that have to be cleaned. Soot plugs the valve, the EGR cooler, etc. I know I've talked to plenty of Snap-on guys and their Snap-on trucks like, oh yeah, my EGR cooler is clogged or whatever. So that is a possibility. EGR or EGR cooler can do that, can clog. So that's one thing we got to worry about. Just take it out and clean it off. Should be okay, I would say. Now exhaust after treatment. So after we've already had combustion, we can have an oxidation catalyst, the diesel particulate filter, which is going to hold the soot, exhaust temperature sensors to monitor everything along the way, DPF back pressure sensor or DPF differential pressure sensor, we could call it, and a hydrocarbon dosing valve, and that's mainly for the DEF to treat the soot. So the diesel oxidation catalyst is going to convert hydrocarbons, and it's going to oxidizes dosed fuel during active regens as well, and then converts nitrous oxide to oxides of nitrogen. Anyways, oxides of nitrogen into nitrogen. So used during passive DPF regeneration is when that happens. And what is a DPF? You may have seen this graphic before, but it's got a bunch of little elves in it that are going to catch that soot, store it, and then when it's done, it's going to burn it, right? That's obviously not really what happens, but that's the basic idea, right? It's going to catch it. It's going to catch that soot before it makes it out in a substrate here, and you see it's in every other type of pattern. So we have the closed substrate, which is where it ends up going out, and then we have the open substrate pieces where it's going to go in, it's going to collect the soot, and then the cleaner exhaust is going to come out the back. Right? Now, what will happen over time if we don't do a regen and we don't clean it up enough, or if it's not running well, we could plug with soot. So we can see there, that one's probably pretty well failed with that. Probably going to need to replace or rebuild that. There are places that rebuild DPFs. But in this case, that would definitely need a replacement or a rebuild. Now, how do we clean it out? We could do a passive regen. That's when the DPF temperatures are high enough to burn the soot from the DPF without needing extra fuel added. It only happens under high load situations, like say towing or climbing a hill or something like that. Active regen can be initiated by the PCM or a scan tool. And that's where extra fuel will be added to the exhaust to raise DPF temperatures to approximately 1,025 degrees Fahrenheit, which will burn the ash off. And then there's also a park regen, which can be initiated by the dashboard switch or sometimes a scan tool, depending on the vehicle. And that can be used when attempts at active regens fail. And you're going to see warnings in there too when you're trying to do a regen that, oh, hey, it's keep it away from stuff that could burn, right? So that's what you would see. So melting as well. If it gets a little out of hand, the temperature gets a little out of hand, it could melt that DPF as well. We can see which way it flowed, and that kind of melted that way. Or, in extreme cases, it could also break, right? So having it break, obviously not ideal. So once again, that would need to be replaced or repaired once again if it ever breaks like that. Then, to go along with that, we're going to use the exhaust gas temperature sensor to monitor the regen process. What's the temperature going in? What's the temperature going out? So once it figures out, and it's going to measure multiple points along the way, it's going to see, okay, what's the temperature in, what's the temperature out, and knows whether or not the regen's actually being carried out and working and do it when it needs to do. Sometimes those need to be relearned. DPF differential pressure sensor is going to measure the inlet versus the outlet, and it's going to tell the PCM how clogged the DPF is. Another reading you'll see is DPF outlet pressure, which is basically back pressure coming out of the muffler. So we're going to have two hoses. One goes into the inlet, one goes to the outlet, and it's going to measure the difference in pressure between the front and the back and see whether or not it's clogged. The dosing valve is going to be used to add the extra fuel into the DPF in order to light it up and make it hotter. So that is just an example of one right there. It looks like it's from Cummins. So that's a hydrocarbon dosing valve. It's basically a fuel injector. Upstream from the cat, the fuel will light when it hits the cat and then warms the DPF enough to regen soot. It's plumbed to a diesel fuel line, adds fuel to the exhaust for active and parked regens. Some also have air plumbed in them to better atomize the fuel. So now, in order for the computer to know whether or not it needs a regen, once again, like I said, the differential pressure sensor is going to be key to that. If equipped, it'll have a wideband oxygen sensor to know the composition of the exhaust. Distance traveled, because it can estimate a soot load based on how long it's been traveling or how far. Engine speed, engine load, air mass, engine temps, and exhaust gas temperatures are all measured for that. And you can see on this complete system, look at all these different sensors that are here. So we have the NOx sensor number 1, NOx sensor number 2. That's on the other side of the SCR, right? And this one has the SCR before the DPF. It's going to have the DPF differential pressure sensor, which is going to measure before and after the DPF for the pressures. There's another EGT over here. There's another EGT over here. That's 4 different EGTs on there. So it knows where exhaust gas temperature is here, 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 and here at each different stage. So it knows, it's programmed to know what good looks like for temperatures and stuff. So it's going to go through that. Like we said, the hydrocarbon injector is going to inject additional fuel in here. The cat's going to light it off, and then it's going to burn the DPF. The DEF injector is going to be before the selective catalyst reduction, because that's how that's going to work. And we're going to talk more about there in a minute. And then, the various, there's 2 NOx sensors, one in front, one in back as well. Could be on either side of the SCR too. Just kind of depends on how the manufacturers set it up. So you probably want to look at some sort of diagram to know and understand where everything is. So here's just another example of what that might look like. So we have air and fuel going in here. We have exhaust going in. So we have temperature 1, temperature 2, temperature 3. Then we have differential pressure, front and rear. And then we have coils over here to kind of help spark it up. So we got the fuel gets emitted into there, and then it gets lit up, and then it gets hot, and then it goes in there. All right. So different needs to be 2 different EGTs at least, if not more, just so it reads what's going on before and after everything happens. So that's these T1, T2, and T3, the temperatures. And then we need the pressure sensor as well. So most use 3 sensors. One's going to be between the turbo and the diesel oxidation catalyst. So right here, it's used for comparison to the diesel oxidation catalyst outlet to see if it lights when dosed with fuel. So if it's the same temperature here as it is over here, then I know it's not lighting up the fuel. Another one needs to be between the DLC and the DPF. So see if the catalyst lights when dosed. Also used for comparison to the DPF outlet to see if it's burning soot. And then the DPF outlet here to see if the DPF got hot during a regen. Also to know when the regen is over. All the soot is burned and the temp will drop off once all the soot is burned. So there you go. So computer needs to know what's going on those 3 spots, at least. Then we've been talking about the SCR system as well. It's a selective catalyst reduction system. So it's going to have the catalyst, possibly a decomposition tube, depending on how it's set up, the DEF injector to inject the actual diesel exhaust fluid, the pump, the tank, the lines, the heaters, the assorted things that go along with the DEF, the entire DEF system, NOx sensors, and an ammonia sensor on some vehicles. Now, why does it need an ammonia sensor? Because basically what we're injecting into the SCR system in order to make that work, the main component of that diesel exhaust fluid is going to be ammonia. So it comes from usually it's a man-made urea type system. So what's in urea? Urea is basically, urine. So we have a lot of ammonia in that. When it combines with oxides of nitrogen, it breaks it up into nitrogen and water. So that pretty helpful because, hey, that's part of the air and that's part of the air too. So there we go. So it breaks down things that are bad for the air and then puts in things that are already in the air. So here's an example of a Cummins. So this has the oxidation catalyst and the DPF first. Then it has a decomposition reactor. So that's where the DEF goes in. And then we have the SCR catalyst there that goes out. So a decomposition tube is a space that allows blending on the DEF with the exhaust system. It's most often has some type of blending vanes to assist in the mixing process, so adds a little bit of turbulence in there. It's also where DEF accumulates when the injector fails and when the system is operated at low temps for extended periods. So you'll could have an accumulation of diesel exhaust fluid in there. So here's an example of that, where the injector is, and that goes into the that tube there. Now, like we said, with the DEF system, it's going to have a lot of different things in there. We're going to have the tank, the lines, the pump, the cooling heater. It could be an electric heater as well. And then a level sensor so you know when it's empty. Now, how do I fill it up? You've probably seen the big jugs of it at the store. I mean, they even have it at like Home Depot and stuff. Depending on where you live, they might even have it at the pump. I know the gas station down the street has it at the pump, and you just pump the DEF in. So a lot of diesel trucks go by there. So you got a diesel pump and you got a DEF pump right near each other. So as I said earlier, the NOx sensors are going to determine inlet and outlet NOx readings. It's going to be used in open or closed loop systems. One fault of these is it can misidentify ammonia with NOx. So just be aware of that as we're talking through this next section here. So it can just think, oh, there's a lot of NOx when it's just a lot of ammonia mixed in. That's why some manufacturers, not all manufacturers, but some manufacturers have went with ammonia sensors in there as well as a backup. So it allows much greater NOx regulation. It's immune to other exhaust gases. So this thing's not going to get fooled with excess ammonia after the SCR happens. So the SCR operation, as we said, we're going to have inlet and outlet NOx sensors, so it knows what the NOx level is. And then there's the injector right there. So we can see there's the diesel oxidation catalyst. There's the DPF in this one. The DPF is first. Then it sprays the injector. Then we have the SCR, and then we have another little slip catalyst at the end. And hopefully what goes in is not what comes out. And how are we going to test it? Well, we can test it with the scan tool, but to make it even more accurate, we probably need to add some sort of a exhaust type sensor to it. So in this case, it's a 5-gas analyzer. We actually have a 1-gas analyzer built just for this that only measures NOx. But this is kind of a way to check up on each other, right? So this is using the scan tool to monitor the data, but the data might not be correct. Whoa, this is just animating like crazy. Hold on one second. That's not how I want it to work. Why is this animating? Hold on a second. I'm going to fix this. That's crazy. On mouse click. There we go. That's better. All right. So how does this work? That was just flying by. It's still doing it. Why is it doing that? My goodness, chat. Holy cow. Stand by. That's why. Somebody messed up my slides timing. It's going after half a second. It's changing. I don't know how in the world that happened. All right. That should be better, I think. All right. Let's try that. There we go. Okay. So with nothing going on, we have our 2 NOx sensors. We should see, in this case, we have 300 parts per million going in, and when it's warming up with the injector off, 300 in, 300 out makes sense because we're not doing anything. It's just going through, right? So we're not providing that chemical reaction. So in this case, we would also be measuring 300 parts per million on our readout. So that's a check on the NOx sensor, right? Under normal operation, we're going to have, let's say, 300 parts per million in. Then it gets put into the catalyst, which adds the urea there, right? And then in this case, knocks out 30 parts per million. So it cut it down by 90%. And then we can see this with the scan tool and this with the scan tool. This is just a check on that to make sure that the sensor hasn't failed, right? Or the sensor isn't giving us the wrong information. So 300 in, 30 out, it's working as it should. Total failure, 300 in, injector on, we're adding urea and NOx to this. So we're basically doubling what we have there. So we're doubling the, because it's reading the actual urea as NOx. Remember how we said that it has that design flaw, right? So you'd be able to measure that 300 parts per million in, 300 parts per million out. So if you double check it with this, you won't say, oh, wow, why is it doing that? Well, it's not. It's just the urea is not combining with that. So like we said, it's got a fatal design flaw in there. And in this case, we actually have data from one of the scan tools reading just the, maxed out 1190. Due to their design, typical NOx sensors not only read oxides of nitrogen, they can also monitor ammonia, which can give false elevated NOx parts per million readings, which is why some manufacturers went to an ammonia sensor. Then a partial failure, we got 300 in, we got 300 out, but in fact, if we're going to measure it, we're going to see we got 150 parts per million. So it's halfway working. But according to the NOx sensor, it's reading both the oxides of nitrogen and the urea in there as well. So as you can see, having a check on this is very important because, like I said, it can fail. Those NOx sensors can fail and give you a false reading and a false sense of what's going on with the vehicle. So the only way to truly know is to actually measure at the tailpipe what's coming out the tailpipe. So it's going to give faster fault diagnosis as well. So if you can read what's going in on scan data, because that won't be affected by urea because there's no urea going by the inlet NOx temperature, right? So it's an inlet or an inlet NOx sensor. So if it's reading, say, 300 parts per million, and then the back says it's reading 300 parts per million, but you put the little sensor in there, the NOx sensor or the 5-gas in there, and it's reading less, then you know you got a problem with that exhaust NOx sensor. So like I said, you can have a 5-gas. There's plenty of those out there. Another kind of new to the market, I think it's been in the last year or so, has been the single gas analyzer. It's a Blue Point branded one. And this just reads NOx. And it was designed specifically to diagnose SCR systems. One of our industrial DSDs came up with the idea, and he shepherded it all the way through and brought it to market. So thank Joe Rappa for that. But the company that makes them for us actually provided this chart to me as well. So let's say, for example, your front NOx sensor is 400. You're reading at 40 at the back. The NOx analyzer as well is reading 40 out the back. Then you know it's working good. NOx sensor 1's reading 400. And out the back coming 800, but you're reading 400. That means it's getting straight through, but you got a problem in the SCR. 150 in, 300 out. That's a problem. That's NOx sensor problem. 600 in, 400 out. That's NOx sensor 2 problem. 400 in, 400 out, 400 reading. It's just not doing anything. It's either not injecting DEF or it's contaminated. And then 400 in, 400 out, but I'm reading 250 means a partially failed SCR system. So just an example table, just use as a guide. Your mileage may vary, but I think that's a pretty good way to read in and out. You can't just rely on the sensors because, like I said, they can be fooled just by that. So let's take a little live walkthrough on the scan tool and see a few different things that we might be able to see here. Let me pull it up. There we go. All right, got a couple vehicles. First one's a Mercedes Sprinter. So as far as with Mercedes, I know this trips people up a lot. So with Mercedes, they are looking for the AdBlue system. I know this is probably more common in Europe because we don't necessarily call it AdBlue over here. We call it like Blue DEF or whatever. Those are brand names. So we're actually just talking about the diesel exhaust fluid in general, but it's so prevalent in Europe that they call it AdBlue, the AdBlue system. And on our scan tools, it's actually in a separate section, engine-related systems and controls for diesel, selective catalyst reduction here. So we would actually go in here and we'll pull it up. And I'm just going to pick this one. And we can see we got codes and data, right? So your data, like your fill level, the temperature values, test values, etc. But under functional tests, we have special functions in here for resetting the calculated fill level, AdBlue return, visual leak test, and dynamic test of the delivery pump. Actuator tests are for the switchover valve, delivery pump, tank heating element, set the metering valve to 50% to 5%, pressure line heating element, and delivery module heating element there. So that's all the SCR stuff is in that one section on Mercedes vehicles. And every time you back out, you got to do a key cycle. Okay, and then the DEF, the DPF stuff, all the other, the particulate filter stuff is going to be under engine. And in this case, we got codes and data, right? So maybe in the data here, we got a lot of different data sections. So NOx values, perhaps you might want to use for the verifying the SCR, right? Upstream and downstream, and then status of the sensors. So that could be helpful. Different calibration data and stuff like that. Functional tests, we have special functions and would be under adaptations, but there's also injector programming too. Many diesels, mostly direct injection diesels, but many diesels require some sort of a coding or programming for the injector. So you would go in here, in this case on the Mercedes. You're going to use the QR code on the new injector, and then we're going to enter a 7-character QR code in here. You're just going to pick whatever injector you need. You're going to type it in. In this case, we don't need to do that. And then all of your DPF stuff is going to be under adaptations. So you can see replace the DPF entirely, teaching to use DPF. Let's see, regen while driving, teach-in process after replacement of the metering valve. So some of the SCR stuff is in here as well. Replacement oxidation catalyst, teaching of zero quantity calibration values, pressure regulator valves, pressure sensors, DPF pressure sensor there. So a lot of different relearns need to be done. Reset learn values of NOx sensors. So once I replace a NOx sensor, upstream and downstream, or either or, I would have to go in here and make sure the engine's not running, and it's just going to do a simple reset on the system. Hopefully I don't get stuck here. We'll give it a few seconds. Oh, we're good. I think. Yeah, wait 10 seconds. There we go. Function complete. Yes. Okay, cool. Also on this, I'm not sure, but let me see. We even got a component test here. See if we have it. Nope, not on that new. All right. Never mind. All right. Let's pull up F350. So that's going to have some slight differences as well, of course. So in this case, we do not have extra down here. It's all going to be under the engine. So all my diesel emissions stuff's going to be under engine. So we're going to have functional tests and then special functions. And then there's SCR functions. They're all in one menu. DPF, 2 different regens in there. So let's go into SCR. Dosing measurement test, system emptying, system refilling, system visual leak check. So all good things to use for that. This has fuel injector correction factors, which is also that injector coding that I talked about earlier. Static regen, procedural command and DPF regeneration. A manual DPF regeneration may take up to 1 hour to complete. For static, this test will increase the engine speed to a high RPM for an extended period of time. If you chose the dynamic regen, the test will require the vehicle to be in motion for the duration of the regen. So we chose the static because we're not going to drive it. Always perform DPF manual regen procedure outside. Don't do it inside because you're going to get a whole bunch of soot and a whole bunch of smoke and stuff inside, and you don't want that. The exhaust system, adjacent components, and exhaust outlet temperature are very hot during this procedure, over 1,000 degrees Fahrenheit, which increases the risk of personal injury, keep people on combustible materials away from the hot exhaust system. So they're going to warn you. Confirmation conditions and warnings when running DPF regeneration. Do you want to continue? Have you met all the specs? Yes. Turn the ignition on. And then it's going to say what the soot load is. Obviously, this is a dummy number. Above 200% is clogged. So it's going to tell you what the actual set is and whether it needs it. In this case, percentage of soot load is higher than the maximum limit of the Performa DPF regen. Prevent dangerous overheating of the diesel particulate filter. DPF regen has been disabled. So if it's over that 200%, it's not going to let you do a regen. And that's pretty common across the board. I know Dodge has the same thing with Ram. There's a certain code that says, I forget which one it is, but there's a certain code. We get a phone call on it all the time about, it's too full and now you can't regen it. So it gives you an issue with that. Oops, I wanted to pull that one back up again too, because we should have got a component test on this one with the 6.7 diesel. Yep, so if we go into engine, and then we have diesel emissions control here. So we've got a component test on the DPF differential pressure sensor. So you can go in there, see what that kind of looks like. And then let's see, particulate filter pressure sensor as well. It's going to be a little different, I guess. Let's see, NOx sensor. We can test the NOx sensor. All right, so it's going to tell you how that works and tell you how to test it. Reductant injector, reductant pressure line heater assembly, quality module, reductant pumps, all sorts of diesel stuff in here. Water and fuel sensor could be important. EGR, we talked about that. AGTs, talked about those. Exhaust pressure sensors. So all sorts of different things specific to the diesel emission system are also available in guided component tests depending on the vehicle. Next one I want to do is a Silverado because that's a little bit different once again. All the manufacturers do it a little bit different. This one has a couple diesel-related modules, so glow plug control module, but that's not necessarily emissions related. We go into engine and functional tests. We have DPF tests set up, and we have reductant system warning test. So let's go to filter tests. It's going to give a regen enable, service regen, pressure sensor reset, and catalyst reset. So those are important. Reductant service bay test. What's our module setup? Injector flow rate programming in there as well. Output controls. Let's see. We might have stuff in here too, I'd imagine. EGR, cooler, EGR valve, and fuel injector flow test for the after treatment, EGT sensor reset, fuel injection cleaning procedure, NOx catalyst reduction loading reset, NOx catalyst reset, sensor 1, 2 reset. They have to be reset when they get replaced too. Reductant heaters, reductant injectors, reductant pumps, system data, turbocharger vane position actuator. We talked about that as well with the variable geometry turbo. So a lot of different functions required, and they're in there. Probably some guided component tests too. And then we have a Jeep Renegade. So that's a little bit smaller of a diesel. It's not a V8 diesel. It's got a 2-liter little diesel in there, but we got coverage for that as well. In this case, I picked a 22, so I got to wait for security link. Okay. And then in here, this has the dosing control unit for the diesel, so that would be the that should be the SCR as well, I think. That's just codes and data. What's they got for data in there? Yeah, SCR stuff in there, urea data and stuff. Okay. So the majority of this one's going to be in the engine as well. So under functional tests, let's see, variable swirl, turbocharger pressure actuator, and that'll be part of that DPF lamp to turn the lamp on. System tests, going to be EGR, high pressure and low pressure valve test, variable geometry turbo test. Let's see, throttle valve tests, miscellaneous functions. It's going to have NOx sensor replacement. Once again, you got to reset the NOx, particulate filter regen, particulate filter with integrated pre-cap replacement, rail pressure sensor replacement, injector replacement. Once again, got to recode the injectors. Low pressure valve replacement, high pressure valve replacements, EGR turbo replacements. So A lot of different things need to get done in there. That must just be NOx sensor, right? Or when the catalyst itself has been replaced. There we go. All right, and let me see. Maybe, maybe not. Not sure on this one. Haven't verified it. No, not for that engine. All right. So that is diesel emission systems. Hopefully you learned a little bit to help you out. Next time you might want to tackle one of those lighter duty diesel emission systems. Definitely the double checking of the NOx system, I think, is of high importance there because you could be fooled. All right, let's talk about next week. Next week, we are talking about our ADAS, OEM-specific ADAS training, and it's going to be VW and Audi again. So we're going to be going back through these last 6 weeks we've done, and we're going to be cycling back to VW and Audi. So hopefully you can join me again. Actually, it will be a pre-recorded session next week, I will tell you, because I'm traveling to our big franchisee conference that is down in Orlando, Florida, which is going to be next weekend. So I am traveling down on Tuesday, so you'll see a pre-recorded one, but you can still watch, you can still ask questions. We'll still be around. So if you want to catch that live, VW and Audi, 6 and 9 Eastern. If you want to register on Zoom, it's snapon.com/OT. You can watch it there. Otherwise, the 6 p.m. Eastern class goes live to YouTube. 9 p.m. Eastern class goes live to Facebook. And if you want to subscribe to our YouTube channel, just click that QR code or scan that QR code with your phone, and that'll get you there. If you want to see any of the other sessions in this series, anywhere from intro to ADAS through, this is episode 120. So that's kind of a milestone, I think. 120 episodes, including this one. So everywhere from ADAS to ADAS specific training, vehicle maintenance functions, diesel emissions, and everything in between. So they're all about half hour, 40 minutes long, give or take. So if you want to check those out, once again, they're all free. Go to youtube.com/snapon diagnostics, and there's a playlist for live training. Also, do we have your email address? If we do not have your email address, you may be missing out on some interesting articles and such. So technical focus articles, SureTrack blogs, quick tips, new product releases. They send out my my schedule periodically. So if you scan that QR code, brings you a form you can fill out, and it'll put all your information in, and then you will start receiving these emails. So that's a wonderful thing as well. All right, time for questions. If you are watching on Zoom and you came in a little late, if you want to ask a question, just find that Q&A button top or the bottom of your screen, and then submit your question there. Otherwise, on YouTube, you can use the live chat as well. So let's see. I got one on Zoom so far. Jay McCall says, thanks for the class. I try to stay away from the diesels. Hey, you know, it's a special breed, I guess, to diagnose that stuff. But hey, I will say some of the stuff that I talked about here is coming this way for gasoline as well. Gasoline particulate filters are a thing now. They're slowly making their way over to the States. They're a little bigger over in Europe, but hey, they are on the way. So you may have to deal with some of this stuff anyways. Over here for gasoline particulate filters. So just be aware that's coming if you haven't seen it yet. Let's see, go to YouTube. So Brandon said before we even started, diesel emissions are about to be ended. I haven't really heard of that. I suppose it could be a change coming down the road. But I will say, even if it does end, there's going to be a good decade worth of vehicles that are going to have it or more. Because when diesel emissions start back, what's 07, 010, and 2010, something like that, right? All right. So I have another comment from Zoom from Anonymous. So I'd say thanks as a former state DOT worker and someone wanting to get in this line of work. And I use Haynes and YouTube and A1 Auto videos, work for Jeep XJ 1998. There you go. So hopefully you stumbled upon my videos and you found them, and that'll help you out down the road for some of this stuff. All right. Back to YouTube. Nick says hello from England. Thank you very much, Nick, for joining as always. He loves his Zeus. And let's see, JLE Lobo says hello as well. Thank you for attending as always. Nick also has the advice of when topping up your AdBlue or your DEF or your whatever you want to call it, please use OEM AdBlue because of temperature additives. Very good. Use the Diesel Talk with Tony Salas said it, and Joe Diagnostics also said it. So Joe Diagnostics would be Joe Rappa, our guy, I think. Outstanding tutorial, he says. Thank you, Jason from JLE Lobo, and thank everyone for watching live on YouTube and watching live on Zoom. With that, that's the questions. So thank you very much. Thank you for taking a little bit of time out of your day. Spend a little bit of time with me. Hopefully you learned a little bit more about diesel emission system that you might not have known before. Hopefully you can apply it down the road, right? With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.